vocabulary words for how we predict things. There's the word, and it's called extrapolation. I know it seems like a extrapolation, and I want to highlight the word extra on that. Like, what does it mean to do something extra? More, beyond. So extrapolation is when you use your line to predict beyond the last data point or before the first data point. It's extra. It's beyond the data set. So we're going to write down using a trend line to make a prediction outside the data points. By outside, just realize that that could be on the low end or it could be on the high end, but it's outside where the first and the last data point lie. And the second vocabulary is interpolation. From looking at the graph, what do you think that means? If you had to guess. Yes, so you're still using your trend line, not the points, but this time you're going to make a prediction within where the data lies. Okay, so there are, well, I don't want to see if there's, yeah, I'm going to talk about one other thing that I don't ask on this, but there's a couple ways that I can ask about predictions. I can ask you to look at on the y-axis, or I can ask you to look on the x-axis. Make sure that if I say predict using the line, make sure you're using the line. If I ask about the actual data, then use the dot. Predict the amount of ice cream sales on a 20-degree day. So we're going to go over to 20 degrees, and we're going to go up to where it hits our line, right here. And let's kind of just bring that over across here. And what would be your best estimate for the ice cream sales on that day? What do you think that is? Like $450? Make sure we put a label on it. And then did I make a prediction within the data set or outside of the data set? Within, because it's like between my first and last point. And so we would call this interpolation. And the reason why is it's within the data set or data points. Yes. If you give me a coupon, give me one of those. All right, predict the amount of sales on a 30-degree day. All right, let's go over. Uh-oh, is 30 on here? So let's do a little work. If I'm using the same scale, this is going up by 2s. Approximately that would be about 28, wouldn't it? I'm just trying to use the same. And maybe where the edge of my paper is would be like 30. And then, what do I have for a straight? I'm going to kind of just try to extend that line. I would maybe use like the side of your paper or something. And it looks like it hits up here, and I kind of bring that over, and I'm going to have to make some kind of prediction. What do you think, Frank? How high do you think that is? You want to call it 800?
Yeah.
So that would be 800 for the sales dollars. I clearly had to go extra, right? Beyond. So this is extrapolation. And I went beyond the data points. Okay. Let's find the slope of the line. Well, it's going to be an approximate, I can tell you that. Let's start right here. To me, that looks like slightly below 100. Do I know what it is exactly? Nope. But I can tell you the x coordinate's 12. And why don't you give me something close to 200? Can we do like 190? As long as you can show me some reasonable numbers, I'm good with that. All right, let's do another one. Hey, how about let's use the point we found earlier on. Remember we found for 20, we said it was about 450?
Yes.
Okay. So I'm going to do my rise over run.
I think I gave them one to you for like homework assignment or something like that.
Okay.
Receiving.
Do you feel, is it like an emergency? You have to go. Just go. Then just go. 450 minus 190 would go on the top. How far is that? 450 minus 190. And then 20 minus 12 would go on the bottom. Let's see. 450 to 190 would be 260. Is that right? Can somebody check me on that? Divided by 8. Okay. Why don't you give me that division, Haley? Looks like you have a calculator if you wouldn't mind helping me out.
32.5.
Okay. I'm going to call that 3250. And that is going to be the increase in sales, ice cream sales, per 1 degree increase in temperature. Bless you. Okay. This might look familiar to you because we actually, yes.
So when you would ask for the slope, why didn't you just, like, why did you minus, or do 450 minus?
I couldn't
instead
find
of-
any that were exactly on the, you know, like
Well,
a,
I'm saying, why didn't you just do, isn't it just rise over?
Mhm. That's what I was doing.
But why did you, like, divide?
This is my rise. That's how far it went up. 190 up to 450.
Oh.
And this is how far it went over. 20
Okay.
minus 12. But on a lot of the other ones, it was right on a grid mark,
Yeah.
so I could easily just count.
Okay.
I just did subtraction because it wasn't quite on the grid line. Okay. George's, this is the heart rate thing that we were looking at earlier, actually, on Friday, I think it was, or it might have been Thursday. This is the heart rate in beats per minute, and based on their age. So George is 35 years old. What is his approximate heart rate? So going to 35, I go up here, I bring it over. What do you want to call that?
122.
Sure. 122 beats per minute. Extrapolation or interpolation? Okay. Sally is 5 years old. Sally is 5 years old, so Sally's right here. What's her heart rate approximately? I would call that 138 beats per minute. That is before the very first data point. Thank you. So I would call that extrapolation. Okay. Now this one I don't really like, the 110 beats per minute, because this is where you have to be careful. John has an approximate heart rate of 110 beats per minute. There is a data point that's 110, but is that data point on the line? No. So if I ask you to make a prediction, then we do want to use the line, and we would want to know, when does the line look like it would touch 110? And it looks like to me that it would be after probably like 55 or beyond. So I'm going to call that about 60 years old. And again, this is going to be beyond the data set, so this would be extrapolation.